Now we'll see directly the preparations of alkanes. Okay, so what are the preparations of alkanes? So from all the compounds we can prepare alkanes, almost all. So first we will see from alkenes and alkynes. From alkenes too we can prepare. From carbonyl compounds we can prepare, alkyl halides we can prepare. Okay, acids we can prepare. So like that. So first one is from alkenes and alkynes. How can you prepare? What is the reaction name? Here some named reactions will be there. You have to remember the named reaction and also the reagent involved in that. Understanding? Reagent also. So from alkenes and alkynes, how can you prepare? Alkanes means just by reduction. So by reduction, that name is Sabater-Sanderson. Sabater-Sanderson reaction. Okay. Sanderson. Sanderson reaction. Okay, name not required. Yes. See, if you take an alkene here, what is the reagent? Alkene, hydrogen in the presence of nickel. Catalyst here, you will get CH3. Okay, or else you can take an alkyne, but 2 times you have to do the same catalyst, so you will get alkene. So this is very easy reaction. Okay, so from alkenes and alkynes. Here, what are the important points to learn? It is a syngention, means both the hydrogens will come on the same flame. If Br2 by CCl4 is there, that is anti-addition, I told you, anti. So this is what addition? Syngention. So suppose if you take an unsymmetrical alkanes, then also both hydrogens will be added from the same position. Both the hydrogens are forming in the same. Next one. From alkyl halides. Is it clear, children? Next one. From alkyl halides. There are 4 methods. From alkyl halides, we can prepare alkane in how many ways? 4 ways. Mainly. So what is the first one? Wood reaction. Have you seen? Have you heard about it? What is Wood reaction? It is also a named reaction, right? So 2 moles of alkyl halides reacts with 2 moles of sodium. 2 moles of alkyl halide reacts with what? 2 moles of sodium. Reacts with 2 moles of sodium in the presence of dry ether. These are the 4 conditions. In the presence of dry ether. So here we have to take dry ether, because if any water content is there, means that will react with sodium. Sodium and water is highly explosive. Okay. So 2 moles of alkyl halide reacts with 2 moles of sodium in the presence of dry ether to form even number of alkenes. What you will get, children, here? Even membered of alkene. Even membered alkenes you will get. Even membered alkenes. Okay. So only three things. What you have to remember? 2 moles of alkyl halide, 2 moles of sodium diether. These three things. So what you will get here? Even number of alkenes you will get. Means suppose if I have taken like this. This is the general mechanism, general reaction. NaX2 will go and you will get an alkene in the presence of dry ether. So if I take methyl chloride, they will give like this. Methyl chloride on Wood's reaction forms. What you will get, children? Methyl chloride, if you do Wood's reaction, what is the substance form? Ethane plus NaCl. Plus NaCl. So this reaction is not suitable if both the alkyl halide are of different types. So this reaction is not suitable if both the alkyl halide are of different types. Why? Why it is not used if the alkyl halide are of different? Anyone? Why can't we use two different alkyl halides? Drawbacks or limitations of this reaction is limitations. We cannot prepare methane. We can't prepare methane from this reaction. So this is the previous NEET question. Which of the following alkene cannot be prepared by Wood's reaction? So what is the answer? Methane. Methane can't be prepared by Wood's reaction. Okay. Second drawback. Odd number of alkenes cannot be prepared. So you may have doubt, methane is also an odd, but methane generally different from other odd alkenes. Okay. Odd membered alkane cannot be prepared. Odd membered alkenes can't be prepared. Can't be prepared. Why? So if you take two different alkyl halides, different alkyl halides, mixture of alkanes are formed, children. What will be formed? Mixture of alkanes are formed. How? See, 1 mole means you will have Avogadro number of molecules now. So if you take, if we take different alkyl halides, then mixture of alkanes are formed. Mixture of alkanes are formed, and their separation is difficult. Their separation is difficult. Why? Because of close boiling points. So this is the third drawback. First one, we cannot prepare methane by this reaction. Methane, there are having some other reactions, I will tell you, which are very important. And odd membered alkanes also can't be prepared. Means odd means what? Propane, pentane. Okay, 3 membered, 5 membered, 7 membered. These things can't be prepared. These things can't be prepared because you are taking the same type of thing. See, if you take one-membered alkane, then it will form. One-membered alkyl halide. If you take one-membered alkyl halide, means what? Methyl halide. So what is the product form? Ethane. If you take two-membered alkyl halide, then it will form butane. If you take three-membered alkyl halide, then it will form 3 plus 3, 6, hexane. So whatever you take, 1, 2, 3, 4, you are getting always double the number. Means you are getting even membered alkane only. You are not getting odd. So if you take two different things, then what happens? We will see. Methyl halide and ethyl halide I am taking. Two different things. You may expect propane here, right? Because methyl 1 carbon, ethyl 1 carbon is there. These two on combination you will get propane. But in this reaction, it will form C2H6 because of these two molecules. Avogadro number of 1 mole you are taking now. In that many molecules will be there. Avogadro number 6.023 into 10 power 23 molecules will be there. So some of the methyl halides will combine with same methyl halide and you will get ethane. Understanding or not? And ethyl halide also, it combines with one more ethyl halide to form butane. Some methyl halides and some methyl halides will combine to form propane. Okay? So this is the drawback. You may get doubts, sir, we are taking only 3, you are doing those many. Means in that mole means many molecules will be there. So there are the possibilities. Some of the methyl halide will react. So you will get ethane. With 1 carbon ethane will form now. 2 carbons butane will form. And some of these one-membered and some two-membered will combine to form propane. So here ethane, propane and butane. These are successive members. So they have close boiling points. Right? So if the boiling points are very similar, we cannot separate them easily. So this is the drawback. Understanding? So if you take two different alkyl halides, mixture of alkanes are formed and their separation is difficult. Why their separation is difficult, children? Because why their separation is difficult? Close boiling points. Because of close boiling points. So this is the third drawback. Understood? So this also previously asked, which of the following alkane cannot be prepared by the combination of methyl halide and ethyl halide? Methyl halide and ethyl halide, which of the following can't be prepared? So the option is this combination: ethane is there, propane is there, butane is there and pentane is there. So what will be the answer? Pentane. Understanding or not? Any doubt? Which of the alkane cannot be prepared by taking these two alkyl halides and doing Woods reaction? So these are the main things about Woods reaction. So this is the first method from alkyl halide. So second is also there. Okay, children, clear? Second one. Same reaction, if the reagent is different, like zinc, that is called as Franklin. What reaction that is? Franklin reaction. Means same alkyl halide, two molecules will take, but instead of sodium, what is used, children? Zinc is used. Instead of sodium in dry ether, if zinc is used, then the reaction is called as Franklin reaction. So Woods reaction and Franklin reaction are almost similar, but what is the difference? Instead of sodium metal, we are using here what? Zinc metal. That's it. So this is called Franklin reaction. This is also from alkyl halide, right? First one is Woods reaction from alkyl halide, and second one is Franklin. Right, children? Same. Third one, reduction. reduction with zinc in the presence of HCl or lithium aluminum hydride. So alkyl halides on reduction forms alkane. Alkyl halides on reduction form alkane. So what is reduction, children? Addition of hydrogen. Here one H, here one H you can add. So what you will get? Methane only. Ethyl halide if you take, you will get ethane. If I am taking ethyl halide, then I will get ethane. Right? Like this. This is the third reaction from alkyl halide. And very important is the fourth one. That is called Gilman reagent. What is that? Corey-House synthesis. In that we will use Gilman reagent. These three things over. The fourth reaction from alkyl halides is Gilman-Corey-House synthesis. Corey-House synthesis. In this, which reagent is used, children? Gilman reagent. Okay. So what is Gilman reagent? Dialkyl lithium cuprate. Dialkyl lithium cuprate is called as Gilman reagent. Okay. Right. So we will see what is that and how it is prepared. So it is prepared when alkyl halide is treated with copper. Alkyl halide, anything you can take. Whenever it is treated with copper metal, then you will get RCuR. This is Gilman lithium copper. So dialkyl lithium cuprate, I told you. Direct reaction we will see. 2RLi plus copper. Preparation once. They won't ask preparation, but the reagent is important. Copper bromide. Yes. Now we will get dialkyl lithium copper R2CuLi plus lithium bromide. Okay. Now see, children, our alkyl halide R dash X I am taking for reference. That is the preparation, not that much important. Preparation is not that much important, but the reaction is very important. Alkyl halide plus dialkyl lithium cuprate if you take, then this R dash and this R2. R2 means 2R, children, here. 2R. So that will form R dash plus RLi plus cuprous halide. So this is the, once again I am telling, alkyl halide plus Gilman reagent will give alkane plus alkyl lithium plus copper halide. So this is called as Gilman reaction. Now, what is the difference between Woods reaction and Gilman reaction, and what is the similarity between Woods and Gilman? This is very important. Understand it? So what is Gilman reagent? Dialkyl lithium cuprate. Okay. So here also even number of alkanes are preparing now. Okay. If I take here CH3, here is CH3, then I can prepare ethane. Okay. So but this reaction can be used to prepare both symmetrical and unsymmetrical alkanes, or you can say both even and odd membered alkanes. Both even and odd membered alkanes can be prepared by this, except methane. Again, methane can't be prepared by this reaction, children. These are the important points. Methane can't be prepared again. So now, what is the similarity between Corey-House synthesis and Woods reaction? What is the similarity? Yes? And what is the difference? Tell me. Second bench, tell me. What is the similarity between these two and what is the difference between these two? Woods and Corey-House. Yes. Similarity is methane can't be prepared by both the methods. That is the similarity, correct? Yes. Methane we can't prepare odd number, right? Methane is odd only, but I am telling you methane is different from other things in this case only. Okay? Means except methane, methane also can't be prepared. But in Woods reaction, you can't prepare 3, 5, 7, 9 like that. But Corey-House synthesis we can prepare 3 member, both even and odd we can prepare. But in odd number, what can be prepared? What can't be prepared? Methane. Except methane, every odd numbered alkane can be prepared in very good yield. Very good yield. See, suppose I have taken methyl chloride, children. Methyl chloride I have taken. And dimethyl lithium cuprate I have taken. Doubts you keep. So you will get methane. Understanding? Because in this one will come and in this one will come. That's all. This methane one and this methane one. Now suppose same methyl chloride I have taken and I used diethyl lithium cuprate. Means I can change this one or this one. Anything I can change. Any one alkyl group. I can change this as ethyl and this as methyl. Then what I will get? CH2, CH3, CH2. You will get a propane. Means this one member, this two member. These two together we will get. Byproducts I am not writing. Okay? In this way you can prepare ethane, propane and butane also. If you want butane, what you will do? This ethyl and this ethyl you keep. This also ethyl chloride you take. And this also ethyl diethyl lithium cuprate you take. So you will get. Or else, this only one thing. This you take 3. 1 plus 3. That combination also you can do. Yeah, tell me what is your doubt? Tell them. Any doubt? First bench. Not in this. Fine. So this is about Corey-House synthesis. We will use Gilman reagent. Now, in short, from alkyl halides, how can you prepare alkane, children? From alkyl halides, how can you prepare? Many methods are there, but these are the 4 methods. First one is Woods, right? Next, Corey-House synthesis. Woods and Corey almost similar, means in product wise. After that, reduction with lithium aluminum hydride. Correct. Alkyl halide with lithium aluminum hydride. Very good reducing agent. Next one more we have seen. What is that? Franklin. So in these 4 named reactions we got or not? In that way you can remember the named reactions. So Woods reaction, Corey-House synthesis, Franklin. These all are named reactions only. No? So while studying you have to study in that manner. Right. Next thing. So Woods reaction over. From alkyl halides it is over. Next we will see. Organometallic compounds. I told you on the day before, what are organometallic compounds? Carbon chain directly connected to metal. Like RMGX is one of the organometallic compound, Grignard reagent, and RLI is also an organometallic compound. Alkyl lithium. Alkyl group directly attached to metal. This is one Grignard reagent and this is also OMC. OMC means organometallic compound. Okay. In both the cases, I told one point. What is that? R will be negative in this. This is very important. Generally, methyl chloride and all that CH3, Cl means CH3 plus and Cl minus you will keep. In all cases, alkyl means plus charge only you will keep. But these are the two cases where alkyl is minus. Understanding? Right. So RMGX, no need to tell now. How can we prepare alkane from RMGX? Tell me. If I take here methyl magnesium bromide, what are the ways to prepare methane? Already this I told you before. Any proton donor you add, you will get methane only, no? So what are the proton donors? We told already this one. HCl, you will get methane. Acetic acid, we will get methane. Acetylene, we will get methane. This one I told or not? So methane, these are the special preparations. And you add ammonia also, you will get methane. Right? H2S, you will get methane. Whatever proton donors are there. Alcohol also, you will get methane. Water, you will get methane. Or big membered alkyl, this one. These all things you will get methane only. But the byproduct is different. In all these cases, what you will get, children? Methane. This we have seen previously. So, generally they will ask which of the following methods methane can't be prepared. A. Woods reaction. B. Franklin reaction. C. Corey-House synthesis. D. All of these. What is the answer? All of these. Understanding? Which of the following reaction methane can't be prepared? First one, Woods reaction. Second one, Corey-House synthesis. Third one, what is that? Franklin reaction. Woods to Franklin to Corey-House. And fourth one, all of this. Means all of this you will get. Then what way you will prepare methane, sir? Means this is the way. Okay? And not only that, carbides also on hydrolysis will give methane. These are the special properties. Aluminum carbide and beryllium carbide, these will give methane on hydrolysis. Okay, what is the next, children? Beryllium carbide or lithium carbide, if you take beryllium and aluminum, Al4C3 plus O, H2O, you will get methane plus 3 moles of methane you will get, children, plus aluminum hydroxide. See the balancing part, is it 4, 3, 12 here, 12, 13, 14, 15 are there. So here also you keep 4. Then how many? 4 aluminiums are there. 4, 3 is 12 hydrogen, 13, 14, 15, 16 hydrogen. So I can write here 8 done. Now children, that's balancing part you check, children. Aluminum carbide and hydrolysis gives methane. Al4C3 plus 12H2O. 3 methane plus 4. 12H2O. See, is it balanced? 12 to the 24 hydrogens are there. Here 12, here 12. Okay, you do with beryllium carbide also. BeC2 plus H2O. Beryllium carbide on hydrolysis will give. Here how many of the water molecules are there? 8, 9, 10. Is it balanced? No. Beryllium carbide also wants to see that. Be2C, beryllium carbide. Beryllium carbide. Have you seen? Hydrolysis reaction of beryllium carbide. Be2C. Okay, wait. This is Be2C. So here 2Be and 2 methane will come. Now check the water molecules. 2 2s are 4 plus 8, 12 are there. So I can write here 6. Balanced? No.